Hi, Math 3 students. Today we're going to go over the 6.1 task. So it says, perhaps you have enjoyed riding a Ferris wheel at an amusement park. The Ferris wheel was invented by George Washington Ferris for the 1893 Chicago World's Fair. Carlos, Carlita, and their friends are celebrating the end of the high school year at a local amusement park. Carlos has always been afraid of heights, and now his friends have talked him into riding on the amusement park Ferris wheel. As Carlos waits nervously in line, he has been able to gather some information about the wheel. By asking the ride operator, he found out that this wheel has a radius of 25 feet and its center is 30 feet above the ground. With this information, Carlos is trying to figure out how high he will be at different positions on the wheel. So let's take a look here. Let's draw on the information they gave us. They told us that the radius is 25. They also told us that this center is 30 feet above the ground. So we can draw that in. This is 30. So they said, how high above the ground will Carlos be when he is at the top of the wheel? So I want you to take a look here. Think about the fact that the radius is 25 and tell me how high Carlos will be when he is at the top of the wheel. So if you look here, since the center is 30, you would just do 30 plus, and then you have to add one more radius to get to the top part here. So that's going to be 25, which is going to give you 55 feet. Then they said, how high will he be when he is at the bottom of the wheel? All right, so if we look, they told us that the center is 30 feet above the ground. However, you're going to be right here, right, when you're at the bottom of the Ferris wheel. This distance, we know the radius is 25. So I want you to figure out what this length would be. If the whole thing's 30 and the radius is 25, how high are you above the ground? Hopefully you did 30 minus 25, which will give you 5 feet above the ground. Then it says, how high will he be when he is at the positions furthest to the left or to the right of the wheel? All right, so if you look, furthest to the left is going to be here, furthest to the right is going to be here. Well, we know that the center is 30 feet above the ground, and if you see, these points here are aligned with the center. So both of those should be 30 feet above the ground as well. Because the wheel has 10 spokes, Carlos wonders if he can determine the height of the positions at the ends of each of the spokes as shown in the diagram on the following page. Carlos has just finished studying right triangle trigonometry and wonders if that knowledge can help him. Sorry, I was practicing before I made the video. It says, find the height of each of the points labeled A through J on the Ferris wheel diagram below. Represent your work on the diagram so it is apparent to others how you have calculated the height of each point. All right, so in order to use right triangle trig here, we're going to want to use the idea, we're going to have to use a right triangle, right? So what we can do is, let's go ahead and start with B. I feel like B here is kind of, we already did A, right? A is going to be 30. We knew that. So we can go to B. Now, what we can do is we can draw in a right triangle. So we've got a triangle like this, all right? Kind of looks like right. So basically, this height here is going to tell us how much to add to the 30, right? Now, what we can do is we need to figure out what this angle is, all right? And I believe it's safe to assume that all of these spokes are evenly spaced throughout the circle. So we know that an entire circle is 360, and we can go around and figure out how many different kind of, I guess, almost pizza pieces we have here, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 different kind kind of spaces here. And they're evenly spaced. So that means that each of these angles has to be 36 degrees. All right. Now, in order to be able to calculate a side length, you also need at least one other side length. We've got our angle, and we need one other side length. Now, looking here, this guy is the radius, right? And if we go back up here, we were told that the radius is 25 feet. So we can put a 25 here. So now we can set up a trig ratio to solve for this unknown part, all right? So we're going to do, let's see, we've got our opposite and hypotenuse, all right? So we'll put an x there for our opposite. We're going to do sine of 36 equals, and we're going to say x over 25. So we're going to cross multiply. We're going to do 25 sine of 36. We can go to our calculator, and remember, when you plug in degrees on your calculator, you need to make sure that you are in degree mode. So I'll show that again, just in case people have changed their settings. You go on your calculator, you go to mode, and you change it to degree. All right, to get there, you just you click the mode button. All right. So we do 25 sine of 36. What am I doing? 25 sine of 36. 25 sine of 36 gives us 14.69. So that means that this value here is 14.69. So the length from B all the way down to the bottom is going to have to be this 30 feet plus 14.69. Which is going to give us 44.69. Oops. Awesome. And maybe what we'll do is we can box our answers here. All right. So now let's go ahead and see if we could calculate C. So one thing we could do is we could draw in another right triangle. All right. And again, all we need to do is figure out this length, and we have to add that to the 30. However, we need to figure out what this angle here is. So I want you to think about what we did for this, the triangle below it. Think about how much each of these notches is worth. What angle do you think should go there? So since we know each of these little notches are 36 degrees, we would just do 36 times 2, which is going to give us 72. All right, and our hypotenuse we know is 25. So we can set up another equation here. We're just going to do sine of 72 equals x over 25. So then we're going to do sine, or 25, I don't know why my pen's doing this, 25 sine of 72 equals x. So we're going to do 25 times sine of 72, which gives us 23.7. All right, so we can go ahead and add 23.7 to the 30 feet. And we get 53.7. So our point C is going to be 53.7 feet. All right, awesome. Now let's go ahead. If we look, these guys are directly across from each other, so they should have the same height here. So we can go ahead and put 53.7 for D. I don't know why it's writing like that. And then for E, we can put in 44.69 feet. Now I want you to look here. What would be the height for F? So the height for F should be 30 feet. All right, so now we got to work on the bottom half of this circle. So what we're going to have to do here is we're going to have to find the height again, However, instead of adding it to 30, we're going to subtract it from 30 because it's going to be that much lower than the 30. So let's go ahead and make another triangle. We got this triangle here. Again, we know that this guy is going to be 36 degrees, and we're looking for this. So we're just going to do sine of 36 equals, oh, and we have to put our hypotenuse in there, which is going to be 25. So it's going to equal our opposite over our hypotenuse, which is 25. Cross multiply, you get 25 sine of 36. And 25 sine of 36 is 14.69. So to find this point G, it's 14.69 lower than the 30. All right, so we're going to do 30 minus 14.69. Oop, I forgot the decimal. Oop, I forgot the decimal again. There we go. So we get 15.31. All right, so now I want you guys to go ahead and calculate how high H would be above. All right, so I'll get you started at least. We've got this triangle here. We know this is 25. We can draw this down. Oops. Make a right triangle. And we know that this here is 72 because it's two of those 36s. So I want you to calculate how high above the ground H would be. So hopefully when you did that, you got that, or I guess actually you should do sine of 72 equals x all over 25. You do 25 sine of 72 equals x, and you find that that x value is going to be 23.7. So you would do 30 minus the 23.7, which gives you 6.3 feet. All right, awesome. And then we can go ahead and write these in. We know this guy is directly across, so we're going to do 6.3 feet, and this guy should be 15.31 feet. Because the reason we can do that is these are both the same distance above the ground. All right. All right, awesome job, guys. Let's see. Let's go ahead. I wanted to go over one of these because I have a feeling a lot of you guys are going to look at this and be a little bit confused. So it says find the other two trig ratios based on the one that is given. So what you have to do here is, we know that sine is our opposite over our hypotenuse, right? So what we can do is we can draw in a triangle. This will be our theta, and our opposite is 4, and our hypotenuse is 5. So we need to find our missing side, right? And we'll just put an A there. So to find our missing side, we're going to have to do Pythagorean theorem. So we can do 4 squared plus a squared equals 5 squared. All right, and we get 16 plus a squared equals 25 minus 16. We get a squared equals 9. You take the square root, and typically you would do plus minus, but this is a length. So in this case, we're just going to keep it positive, and we get that a is 3. So you get a 3, 4, 5 triangle. So now if we're trying to find the cosine of this, we know cosine is, here, I'll write this out again. SOHCAHTOA, right? So for cosine of this specific angle, we have to do adjacent over hypotenuse, which is going to be 3 over 5. And then I want you to look at this triangle. What would be the tangent of this guy? So that's going to be 4 over 3, because that's opposite over adjacent. So with these, what you have to do is you have to essentially set up a triangle and solve for the missing parts. It's actually only going to be one part that's missing. And one thing I want to point out too is you can turn any number into a ratio. You just put it over 1. So for like this guy, you can put it over 1. This guy, put it over 1, and that should help you out.